Hi everyone, I hope you're okay, and I really hope that guys the videos will keep uploading and helping you out. This is the 13th video, guys, which simply means I'm doing question 13. Please do expect a total of 33 questions. You can just take a screenshot, attempt this question, and then come back and compare your answers to mine. Okay, learners use compounds A to C, shown in the table below, to investigate the factors which influence the boiling point of organic compounds. Okay, these compounds, they are just hydrocarbons. Okay, their difference is their molecular mass altogether. This one is 4 carbons. We are dealing with butane. Compound A is butane. Let me write there. Compound A is butane. Compound B, 1, 2, 3, 4. Compound B is pentane. Compound C is hexane. Altogether, we are dealing with 3 different types of alkanes. The types of intermolecular forces that are present within alkanes, they are called London forces altogether. The molecular formula of each, I'll simply have C4 H10, C5 H12, C6 H14. Okay, which one of the compound has the highest boiling point? Remember that, guys, we are dealing with compounds which have the same forces between the molecules altogether. However, the one with the greater molecular mass will have a highest boiling point altogether. And you can say the one with the greater molecular mass, or the one with a greater surface area, because you are dealing with straight chain hydrocarbons over here altogether. This one has a greater surface area as well as a greater molecular mass. So compound A will simply have the highest boiling point. Not A rather, but compound C. Excuse me, guys. Compound C. Okay, then 3.2. For this investigation, write down the independent variable and the dependent variable. The independent variable is just molecular mass, or you can say that's the chain length altogether. The dependent variable, once we change this, we want to see the impact it has on boiling point. So if boiling point is dependent on the changes, so boiling point is the dependent variable. Okay, write down the name of the type of van der Waals forces that occurs between the molecules of compound B. We have London forces. London forces. Actually, all of these compounds, they all have London forces. Okay. How will the vapor pressure of 2-methyl propane compare to that of compound C? Write down higher than, lower than, or equals to. The vapor pressure, remember that, guys, 2-methyl propane, firstly, it has a smaller molecular mass compared to compound C, which is hexane, and secondly, it has a smaller surface area compared to compound C. So that means the intermolecular forces that exist between 2-methyl propane are weaker than that of compound C. So with weaker intermolecular forces, the vapor pressure will be higher. Vapor pressure will be higher. Okay. The learners now compare the boiling points of compounds D and E as shown in the table below. Compound D is an alcohol because it's a primary alcohol, that is, it has a hydroxide ion on the terminal carbon. The IUPAC name of this, I have 1, 2, 3, 4, 5. It's just pentane 1-ol. Are you together? The molecular formula is just C5H12 with an O. And then for compound E, we are dealing with a carboxylic acid. This over here tells me that I'm dealing with a carboxylic acid. Are you together? And the name of this carboxylic acid is butanoic acid because it has 4 carbons on its longest chain. It's butanoic acid. Its molecular formula is just C4H8 with 2 oxygens. What are we asked? How does the boiling point of compound D compares to that of compound E? Okay, firstly, both molecules has a hydrogen bond between them, ne? However, compound D, which is an alcohol, compound D only has one side of hydrogen bond. It only has one side of hydrogen bond, whereas compound E has 2 sides of hydrogen bond. Are you together? Then the second point will be that compound D has weaker intermolecular forces. Compared to compound E, ne? And then less energy will be required to separate the bonds of compound D, and hence it has a lower boiling point. That's how, guys, you're supposed to tackle this question, né? Just stay tuned, guys, and obviously wait for more. Thank you for your time.